Hello everyone, welcome back to Let's Crack JEE English, the channel of Unacademy. And I am Jeetendra Dixit. So here is my profile. Let me check first whether I am live or not. Then we will continue. Yes. So let me introduce myself. I am Jeetendra Dixit. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. So I was teaching quadratic equation, indefinite integrations in this session, and I'll continue that. We are almost about to finish. Now we are left with integration of irrational functions and some miscellaneous problems. So 3 more sessions, and then we'll start a fresh topic. All right. So today I'll discuss integration of discontinuous functions, their formulae. There are some new formulae which I haven't told you earlier as well. So we'll discuss those formulae today. But before the beginning, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform, and you can prepare for many exams on this platform. So if I talk about IIT-JEE and you take the subscription for IIT-JEE, then you get access to daily live classes of all the JEE educators. All means all physics, chemistry, and maths, and also their recorded lectures. So if you have missed something, you can watch their recorded lectures later also. This platform is very interactive. You can interact with your educator through chat, poll. You can participate in poll, and we'll have live quizzes also. So to get the feel of the platform, you can attend the special classes. Special classes are free for everyone, so you can attend the special classes, and you don't need to take subscription for those to attend special classes. So every day there are special classes planned of different educators. So just go and attend these special classes. All right. And through special classes, you learn to know that how to interact with your educator, how interactive this platform is. All right. So everything. So this unlimited access you get once you are subscribed to IIT-JEE, and for that you need to download Unacademy's learning app. And once you download Unacademy's learning app, you can subscribe for 1 month, 3 months, 6, 12, and 24 months, and prices are changed from today. All right. So I was telling you for last 10 days. Now this is the new price list. So see and go and take the subscription. All right. So new price list will be applicable from now. Okay. And for more updates, I'll update you. All right. Tomorrow also. Let's just start indefinite integration. Integration of irrational functions. All right. So first, let us discuss the formulae. 1 minute. So if we have some formula for irrational functions, a quadratic type of expression inside the square root, like a square plus x square, this one, integration of 1 upon under root of a square minus x square, all right, this one, or integration of 1 upon x square minus a square. So far we haven't proved formulae much, but let's prove it now. Let's prove these formulae at least, because we know almost all the formulae. So using those formulae, trigonometric functions formulae, right, we can prove it. So what kind of substitution I should use in this? So in this I'll use x is equal to tan theta, because whenever you have a square plus x square, so you put x is equal to a tan theta or a cot theta, right? Whenever you have a square minus x square, then you put a sin theta, a cos theta, right? Like in this second one, we'll put a sin theta. So let's put it, and after putting x is equal to tan theta, dx will be what? Dx will be sec square theta, all right? Sec square theta d theta. So we'll put d theta dx also. Let's see what will happen. So it will be sec square theta d theta divided by under root of a square plus a square tan square, a square plus a square tan square theta, and see, simplify it. So after simplifying, you'll get this will become 1 upon a. Write this a outside the integral. This a square, a will come out and take it outside. Then 1 plus tan square will be sec theta. So 1 sec will get cancelled and you'll be left with only sec theta. And now you know what is the integration of sec theta. It is sec theta ln of sec theta plus tan theta, right? Divided by a. And now put the value in terms of x. So final answer will be 1 upon a ln of, now what is this tan theta? You can, okay, sorry. So it was a tan theta, all right? It was also a sec square theta. So you'll get a here, right? Then only it will be a square tan square. And then a will also come. So this a will get cancelled, all right? So this a is not there in the denominator. So this a will not be there. So final answer will be what? Ln of, now put the value of tan theta, so that will be sec theta upon, x upon a. This tan theta is, 1 minute guys. So this tan theta is using this x upon a, and sec theta will be what? Under root of 1 plus tan square, so 1 plus x square upon a square, right? Plus c. Now you can take this a common, LCM, so it will be finally ln of x plus under root of a square plus x square, all right, and divided by a, so that you can write minus ln a, and that you can club with this arbitrary constant because ln a is a constant, all right. So in this way, this is the formula, all right. This is the formula which you need to remember. So 1 upon under root of x square, 1 upon under root of a square plus x square is ln of x plus under root of a square plus x square, all right. So I hope it is clear. Now you try this second one also. As I told you, you need to put x is equal to a tan theta. Just try it for a minute. I am coming back. All right. Okay, so now let's put the substitution in this. If I put x is equal to what we will put in this, x is equal to a sine theta, all right. So if I put x is equal to, 1 minute guys. If I put x is equal to a sine theta or cos theta, you can put, so a sine theta, all right. Whenever you have a square minus x square, so this kind of trigonometric substitution can do. So because we have done integration of trigonometric functions and we learned this for these formulae, so it will be 1 upon under root of a square minus a square sine square theta, right? And dx will be what? Dx will be a cos theta d theta, and it is going to be very, very simple. You can say it is nothing but a cos theta in the denominator as well, right? So this a cos theta will get cancelled and you'll be left with 1 only. So it is 1 sine 1 into d theta. Now what is the integral of 1? That is theta plus c. Now put the value of theta from this. So it will be x upon a, and you need to take sine inverse, right? So it will be sine inverse of x upon a. It's very simple, all right? So this is the answer. Similarly, let me write the answer. In this, you need to substitute x is equal to a sec theta or a cosec theta, and the final answer of this will be similar to this, right? Similar to the first one. So its answer is ln of x plus, everything will be same. The only difference is now it will be x square minus a square. So in the beginning it was x square plus a square in the first formula. Now it will be there. So you have these three formulae which you need to remember. So any such expression in which it is 1 upon under root of quadratic, we'll use these formulae, all right? We'll use these formulae. So this is the one first thing. Now let's discuss next three formulae. Now you can have these quadratics in the numerator also, like this: a square plus x square first, second integral of under root of a square minus x square, and third. So you can see the same three form terms, but now this under root of quadratic is written in the numerator. So exactly similar, right? Exactly similar. Now what will be the answer of these three integrations? Let's do it. So let's do the first one. To solve it, we need to apply by parts in this. Okay, so we'll take 1 into this function, because how do we start? Or you can do the substitution also, like the substitution we did in the previous question. Okay, so you can start with substitution, either start with substitution or start with by parts. Okay, so two methods. So substitution I have already told you in the previous proving, right? So let's do it by parts now. Okay, previous questions also you can do using by parts, and these problems you can also solve using by parts. So let's solve it. So under root of a square plus x square as it is, a square plus x square as it is, into, let's take this I is equal to this, into integration of 1, that is x, minus integral of integration of 1 is x, into differentiation of this, under root of a square plus x square is 1 upon under root of a square plus x square into x, right? And 2 and 2 will get cancelled, right? So it will be x square dx. So this is now the integral. Second part is remaining. So to simplify it, we'll add plus a square and minus a square. And after doing so, you can see what will be the answer. It is under root of a square plus x square into x. Okay, now separate it. So 1, it will be integral of, see, this divided by under root of a square plus x square will again make the same question. So you can write that is equal to I. So that is going to be I. This term is going to be I. All right, this integral. Same thing will become here. And the rest will be plus integral of a upon a square upon actually under root of a square plus x square. So let me write it here. So it will be minus I plus integral of a square upon under root of a square plus x square, all right, dx. So this is remaining to do. Now separate this I and I will become 2i. So 2i is equal to this first term as it is x into under root of a square plus x square, all right. And this is nothing but the same integration which we did in the previous slide, right? A square into integral of 1 upon under root of a square plus x square was what? Ln of x plus under root of a square plus x square. So second term will be the same that we did earlier. Now just divide by this 2. So final answer is going to be I is equal to, that will be the formula as well, I is equal to 1 by 2, or you can write x by 2. So 1 by 2 x under root of a square plus x square, okay, plus ln of x plus under root of a square plus x square. Okay, this is the formula which we have written in the denominator. All right, now this will come, now the only change in this will be the same method you need to use. Only change in this will be, okay, a square was also there. The only change in this will be that it was ln of this, now it will be sine inverse of this. All right, so you need to apply the same formula. So let me write the formula of this. It is going to be 1 by 2 of x under root of, now replace this quadratic similar way. So it will be now a square minus x square, everything will be similar, right? Plus, now it will be a square like this, okay, this a square. The only change is that you need to apply the formula of 1 upon under root of a square minus x square in the second term. So that was sine inverse of x upon a, all right, and rest everything. Similarly, in this also, everything will remain same. And what will be the difference? So it is now x upon x into under root of a square, sorry, x square minus a square. This will be now x square minus a square. You need to write the same quadratic which is written here, right? Same term. minus will be there. That is the only difference. In this formula it was plus. Now it will be minus. Minus a square times ln of formula of 1 upon this. So that was x plus under root of x square minus a square. Okay. So everything is same in these three formulae. The only difference is of this term, right? Of this term and this term. And these are basically formulae which we proved in the previous slide, right? For 1 upon of this under root of this quadratic, right? We need to use this formula. So we'll use these formulae whenever we have 1 upon under root of quadratic or under root of quadratic. See how to use it. Let me give you some examples. So if I give you like example like you need to integrate 1 upon under root of 4x square plus 4x plus 5, all right? You need to integrate this dx. So what will you do? Like 1 upon quadratic, how did you do 1 upon quadratic? You made perfect square, right? So in this also you will make perfect square. So it is very simple, straightforward, just make the perfect square in the denominator. So it will be 2x plus 1 the whole square plus 4 can be written as 2 square, right? Now compare it with 1 upon under root of x square plus a square and apply the formula. So that will be in terms of ln a. So ln of this x is nothing but 2x plus 1 plus under root of x square plus a square. So this is x here. So x square plus a square, this whole thing, right? Basically this thing, right? So expand, you can write in this form or in this form which was given in the question. 4x square plus 4x plus 5. This is x square plus a square, right? But coefficient of x is 2, so you need to divide it by 2, this whole expression, right? Because x in place of x, it is ax plus b. So you know what to do whenever you have ax plus b in place of x. You just need to divide the whole formula by a, right? And replace everywhere x by ax plus b plus c. So this is the answer, right? In this way you can apply the formula. Now let's see what will be the answer if you have something like this. 1 upon say minus 4x square minus 8x plus 8x and minus 3 . Okay, let's take minus 1, no problem. Take any number, no problem. Okay, it is like written like this. So let's make a perfect square again. So integral of under root of, so first of all take minus common, all right? So take minus common, it will be 4x square minus 8x, okay? And minus 1 as it is, dx. Then to make it a perfect square, you can see it is 1 upon, this is 2x the whole square. This is minus 2 into 2 into 2x, right? So a2 b is 2, so you need to add plus 4 and minus 4, right? So minus 4 with minus sign and plus 4 will come out, so it will be finally under root of integral of 3, this minus 4 and minus of minus plus 4 and minus 1, so will become 3 minus, inside it is going to be 2x plus 2 the whole 2x minus 2 the whole square, 2x minus 2 the whole square. If you expand it, you'll get the same thing again, all right? So this is the perfect square. Now just apply the formula. So what was the formula of this one up under root of a square minus x square? That was in terms of sine inverse. So let's apply this formula. So it was a big one, right? 1 by 2, first of all, 1 by 2. Okay, just assume it to be x. Later just we need to divide by 2, okay? So everywhere in place of x, it will be 2x minus 2. So the formula was 1 upon 2 x into under root of same quadratic, a square minus x square, right? So a square minus x square, let's not write in this term, but but in terms of the given equation. So you can write this, minus 8x square plus, sorry, minus 4x square so minus 4x square plus 8x minus 1, all right. Then what was it? Then plus of a square by 2. So what is a square? A square is 3. So 3 by 2 is we have written outside. So a square. And then what was it? Sine inverse. This was the fine formula of sine inverse. Sine inverse x upon a. So x is 2x minus 2 upon a. A is root 3, all right. And you need to divide by 2 as well, this 2. So it will be 1 by 4 outside, okay. So this is the answer. In this way you can apply this formula. So I hope it is clear. Okay, so let's learn some more substitutions. What will happen if some other form is given? See, so there are some other forms as well. Whenever you have px plus q, a linear upon under root of quadratic, then what will you do? Ax square plus bx plus c. So let me tell you this as well as this. You can have this quadratic in the numerator as well, right? So in this case, what to do? So there are some particular forms which you need to learn in order to solve the problem, all right. So this is pretty simple, you can guess it because we have already done linear upon quadratic, okay. So it's the same thing. So in this you need to express this numerator, px plus q in terms of k1 times of derivative of denominator, quadratic in denominator, that is 2ax plus b and plus k2, okay, in both, in this, right. And then solve it, then put it here. So see what will happen. Okay, so that is the main point. So I'll tell you through one example. Let's take 2x minus 1 divided by or let's take x minus 4, all right, or you can take 3 also. Let's make it difficult in terms of calculation. After all, it is not difficult. So it will be x square plus 4x minus 5, say, all right. See what will happen. So you need to express this 3x minus 4 numerator is equal to k1 times of derivative of denominator, which is 2x plus 4 plus k2, all right. You can express one linear in terms of other. We have already discussed this in rational functions. Now compare. So it will be 2k1 is equal to 3 and minus 4 constant is equal to plus 4k1 plus k2, all right. So k1 is equal to 3 by 2, k1 is equal to 3 by 2, and put k1, so you'll get k2 also, you'll get 3 by, if you put 3 by 2 it will be 3 by 2, so here k2 will be minus 4 minus 3 by 2, all right. So it is going to be minus 8 minus 3, so minus 11 by 2, all right. So you can write this k1 is, now express this numerator in this term, in this form. So you'll get two integrations k1 is what, 3 by 2, all right. Into integral of, this is linear 2x plus 4 upon under root of x square plus 4x plus minus 5. Let's see what to do with this. I'll tell you. Plus another constant was minus, actually minus 11 by 2. So let's write minus 11 by 2. Integral of, divide the quadratic k2 by this quadratic. So 1 upon, you have got 1 upon under root of quadratic, okay, which you can write x plus 2 the whole square minus 3 square, minus 9 basically, right. So in this you can apply the formula directly. Now let's write the answer. So this first term is nothing but, this is f dash x upon root fx. So you know what is the formula of f dash upon root fx integral? This is 2 root fx, right? We have already done this, 2 root f. So this is going to be 2 root of quadratic. Always write this answer directly, x square plus 4x minus 5. This is done. Okay, so this is the first term, minus 11 by 2. Let's do the second one also. In this also you can apply the formula directly. It is x square minus a square form. So it will be ln of x, which is x plus 2, plus under root of this whole quadratic as it is. So that is x square plus 4x. I'm writing it in expanded form, minus 5, all right. this, and you don't need to divide by anything because the coefficient of x is 1 plus c. So that is the final answer. All right, so you've got two terms. So I hope it is clear. This is linear upon quadratic, linear upon under root of quadratic, and the similar way you can express this second linear into under root of quadratic also. There are some other forms also in irrational, so let me tell you how to solve those forms. So integration of this type, if you have this linear in the denominator, linear into under root of, okay, this is simple, linear into under root of linear. First let me tell you this, or this integration of linear upon under root of linear, all right, dx, or you can have this under root of linear in the numerator also, L1 into under root of linear, or you can have this under root of L2 upon L1, all right. In all such cases, you need to put L2 is equal to t square. Simple as that. No problem. No new thing at all. Like if you have like x plus 1 upon under root of say 2 minus x dx, all right. Let's solve it. So how to do it? You can see under root, it is under root of linear only, okay. And even if you have a quadratic in place of linear, then also whenever you see under root of linear in the whole question and rest of the function are rational functions, so put this linear is equal to t square. Simple. So in general, if I say fx into under root of linear, all right, L2, in this also you can apply this. Make sure fx is a rational function, okay, then it will work. So just put 2x minus x is equal to t square, and it will be dx is equal to minus 2t dt, all right. So let's see what will happen. Put the value of x is equal to 2 minus t square, so 2 minus t square plus 1, and dx will be minus 2, so minus right minus outside, 2 is 2 also outside, t dt, and divided by this under root of t square, which will get cancelled with this t, and you can see how simple integration is this. So it is integration of 3, which is 3t, and integration of minus t square, which is minus of t cube by 3, right? Put the value of t again, so it will be minus of 6 times of t is under root of 2 minus x, plus 2 by 3 times of under root of 2 minus x raised to 3, all right, plus 3. This is what you need to do. So I hope you have got it. Now let's discuss another form. So suppose if you have 1 upon linear into under root of quadratic, okay, yes. Then what to do? Then first put this linear is equal to, see how to start this. Put this linear is equal to 1 upon t, okay. This is the substitution. Start with this. Use it and you know how, you'll get how to simplify it. I'll give you one example and you'll come to know what will happen if you put a linear is equal to 1 upon t. So let's take one example, and through this example we'll understand the process, all right. Now this is a kind of substitution which simplifies it easily, all right. There might be some other things also, it's not necessary that you do it, but this is something which will always work, whatever kind of quadratic it is, okay. You can have some other substitutions as well. So suppose if I'll take one example of x plus 1 into under root of 2x square plus say x, say 4x, all right. Okay, so plus x plus 3, all right, say this dx. So we are putting x plus 1 is equal to t, or 1 upon t, sorry. X plus 1 is equal to 1 upon t. So what will happen? So you'll get dx is equal to minus 1 upon t square dt. Let's substitute it. So it is going to be, see what is going to happen, 1 upon t square dt. This will be 1 upon t, and what is the value of t? So from this you'll get t is equal to uh, t is equal to 1 upon, you need basically x is equal to 1 minus t upon t, all right. So this you put inside the quadratic in place of x. So it is going to be t into 2 into 1 minus t the whole square upon t square. So take LCM as well. It's whole divided by t square, and then t will come out. Okay, so t. Now so I've taken the LCM and I have written t square out, t outside the square root. Then it will be plus 1 minus t into t. Okay, and this will be plus 3t square, all right, like this t and this t square will get cancelled, all right. So that was the main purpose. Now you have got 1 upon quadratic. So now you understood what has happened. This 1 upon linear into under root of quadratic has become now 1 upon under root of quadratic, okay, which we know how to solve it, all right. So you have got this 1 upon minus of dt divided by under root of, if you expand it, you'll get 3t square minus t square, so plus 2t square and 2t square from this. So in total 4t square. So it is now 4t square. All right. This will be minus plus t and minus 4t from this. So it will be total minus plus 4t and minus 4t and plus t is minus 3t. All right. And the constant term will be only 2. So plus 2. Now you know how to solve it. Make it a perfect square and it is done. So this was the integration of 1 upon linear into under root of quadratic. Okay. Now a few more forms. Now it might be, integral of might be 1 upon pure quadratic. Okay, pure quadratic means ax square plus b into under root of quadratic. Okay, quadratic, this quadratic also is pure quadratic. That means x term of x is not there. So ax square, directly I'm writing the form. So form of this type, ax square plus b and px square plus q, all right, dx. So this type, this is another type. So in this type of integration, you need to put x is equal to 1 upon t, okay. So you need to start with this, put this. Whenever you have quadratic into under root of quadratic and quadratic is pure quadratic, then start with this, all right. So let me take one example and I'll tell you how to solve it. Say it is x square plus 2. Let's take one simple example. And it is say x square plus 1, all right. So you'll have to substitute 2 times in this. So second time what to substitute, you'll get to know later. First substitution is this only, okay. X is equal to 1 upon t. So put x is equal to 1 upon t, and then later you can simplify it easily. Later you'll come to know what is the next substitution. So you know dx is equal to minus 1 upon t square dt, right? Perhaps you must be getting why we are putting this t, because this t square is going to cancel like in previous form. 1 upon t square dt. Okay. Now this, put 1 upon t in this, so it will be 1 plus 2t square, all right, divided by t. If you put divided by t square, I'm sorry. And if you put 1 upon t in this way, so this will be under root of 1 plus t square, and LCM, in LCM it will be t square, so t will come out, right? So this t square will get cancelled, but 1 t will be there in the numerator. So this t is going to help us, and this was our purpose to get this t. Why? Because if I put now this under root quadratic, which is inside the under root, is equal to u square, then the derivative of this t dt will come. So t dt you have, right? So you can rationalize, you can convert this into a rational function by putting t square plus 1 is equal to u square, all right. So you know what are you going to get? This is now next substitution is this. So this is 2t dt is equal to 2u du, and it is going to be t dt is equal to u du, all right. So now this new question will become u du. So t dt can be replaced by u du divided by, and it's done, almost done. Just replace t square by u square minus 1. So 2 times of u square minus 1 plus 1, and this whole thing multiplied by under root of u square. So this u square and u will get cancelled, and now it is a simple quadratic, actually standard formula. So du upon, you have got this 2u square minus 2 plus 1, so it is minus 1. So you know which formula you need to apply. So this is in terms of log. So write the answer 1 upon 2a, so minus 1 upon 2, a is 1, and ln of x square minus a square is x minus a and x plus a, so it will be root 2 u x minus a upon x plus a. This formula you need to apply, right? And divided by root 2 also, because coefficient of u is root 2, so root 2 will also come here. Now put the value of u and then finally put the value of t in terms of x. So final answer now you can write in terms of x by resubstituting the values of u and t. All right. So that is the method. That is another way. So I hope this kind of integration you will be able to solve. So these are particular forms in rational functions which you need to solve. Okay, I'll tell you one more example. Whenever you have under root of 1 upon linear to the power m and linear to the power n, all right, dx, and m plus n is an even number, all right, even number, then put L1 upon L2, put L1 upon L2 is equal to t, all right, put this. Even numbers, mostly it will be 2 or it might be 4 or it might be minus 2 if it is in numerator or denominator, right? So I'm written in general m plus n is equal to even. M can be like 1 by 2, n can be like 3 by 2, okay, rational numbers, not necessarily integers. M and n are your rational numbers, all right? For example, let's see this example, 1 upon x plus 1 raised to 1 by 2 and this 2x minus 1 raised to 3 by 2, okay? So you can see sum of these two numbers is equal to, you can take any one as L1 and any the other one as L2, okay? That is not a problem. So first let us write this in terms of L1 upon L2. So L1 upon L2, L1 upon L2. Let's take this L2 away, no problem. So you can write x plus 1 raised to 1 by 2 upon this 2x minus 1 raised to x minus 1 whole raised to 1 by 2, okay? So I've divided by 2x minus 1 raised to 1 by 2 power, whatever power I have here, okay? Because I've multiplied by 2x minus 1 raised to, divided by 2x minus 1 raised to 1 by 2, I have to multiply also. So this will be 2x minus 1. The sum of these two is 2, right? That is the main purpose. So now 2x minus 1 raised to 2 it will become, okay? It is now perfect square, 2x minus 1. Now what is going to happen here? Why are we doing such so? Because whenever you differentiate linear upon linear, you'll always get constant upon quadratic by differentiating linear upon linear. Differentiation of linear upon linear is constant upon quadratic, okay? Whatever type of linears are these two, okay? L1, L2. Let's see it, okay? Let's put x plus 1 is equal to 2x minus 1 is equal to t. And let's differentiate it. After differentiating, you'll get 2x minus 1 into differentiation of x plus 1 is 1 minus 2 times of differentiation minus differentiation of this 2x minus 1 is 2 into x plus 1 as it is divided by 2x minus 1 the whole square into dx is equal to dt, all right? So if I simplify this, it is going to be, see, these 2x and 2x will get cancelled. It will be minus 1 and minus 2, so overall minus 3 divided by 2x minus 1 the whole square dx is equal to dt. So you need minus 3 here, you already have this, okay? That was the main purpose, to minus 1 by 3. So minus 3 upon 2x minus 1 whole square dx will become dt. So it is going to be dt upon t raised to, so this is root t, right? Simple. You know how simple integration it has become now. So 1 upon root 2, integration of 1 upon root t is 2 root t. So final answer will be minus 2 by 3 root t, and put back the value of t. So what was the value of t? Minus 2 by 3 under root of, your t was nothing but x plus 1 upon 2x minus 1. So this is your answer, all right? So this was one last form for irrational numbers. So We are done with the rational functions. Now let's do some practice questions. All right. So try this one. Now you solve it. Solve it. Solve it by making it a perfect square, and then it's done. It's an easy problem. All right, so let me do it then. This was an easy problem. Perhaps you have done it. Oh yes, I'll make it a perfect square. So integral of dx, take minus sign common, write it minus 6, no problem. If you take minus common, it will be x square minus 5x, all right. Minus 5x can be written as 2 into 5 by 2 into x, all right? So minus 2 into x into 5 by 2, all right? So b is what, 5 by 2? So you need to add plus 25 by 4 and minus 25 by 4, which will come out with positive sign. So plus, because of this minus, minus minus plus 25 by 4. And you can club these two terms, this and minus 6. So it will be 1 by 4 plus 1 by 4. So it is finally dx upon under root of, so minus 6 and plus 25 by 4 is plus 1 by 4, which you can write 1 by 2 the whole square, minus this is x minus 5 by 2 the whole square. All right. Now it is a square 1 upon under root of a square minus x square. So it will be in terms of sine inverse, right? So it is sine inverse of x upon a. All right, that's it. That's it. And coefficient of x is 1, so you do not need to divide by anything. Just simplify it. So it is sine inverse of 2x minus 5 divided by what? Nothing. 2 will get cancelled. All right, so plus c. That's it. So C is the correct answer. Now let's do this. Try this one. Try to find the answer of it. All right, so this one is pretty simple, linear upon quadratic. So you can split it easily. Integration of Uh, what is the derivative of this, which is written in the denominator? It is 2x, which is already given in the numerator. Okay, so you just need to split it. It was easiest problem of the day. Easiest problem of the day. X square plus 1 and 2x plus 3 dx. So derivative of x square plus 1 is nothing but 2x. So split it. It will be 2x upon under root of x square plus 1 dx. This will be your first integration, plus keep this 3 outside, and it is 1 upon integral of x square plus 1, alright, dx. So this is f dash upon root of fx, 2 root fx, alright, plus 3. This is direct formula of what? ln of x plus under root of 1 plus x square. So this is the answer. So now you can write the answer. So A is the correct option, alright. So A is the correct option. Now let's try this last problem as well. So in this you can see that derivative of it is pretty straightforward. X square plus x plus 1 is nothing but 2x plus 1, which is written in the numerator, right? So this is 2x plus 1 upon under root of x square plus x plus 1 dx. So it is f dash upon under root of f dx, right? Which is nothing but 2 root fx plus c. So a straightforward question. So it will be 2 under root of x square plus x plus 1 plus c, alright. So directly you can solve it. Not a problem at all. Okay, so I hope you have got it. Let me also tell you one form which you might get as this. You might get this also. Whenever you have a quadratic px square plus qx plus c in the numerator and under root of quadratic ax square plus, let's take this r, ax square plus bx plus c, quadratic upon under root of quadratic. We did linear upon under root of quadratic. Now I'm telling you quadratic upon under root of quadratic. Nothing new in this. You just need to express this quadratic in the numerator, which is p x square plus which is px square plus qx plus r is equal to k1 times of this quadratic in denominator, that is ax square plus bx plus c, plus k2 times of derivative of denominator, which is 2px plus q plus k3, alright. In this way you can express and then divide this quadratic, so you'll get 3 integrations, alright. So this integration of px square plus qx plus r can be written as ax square plus bx plus c dx. Now divide this whole thing. Now write the numerator in this form, So you'll get 3 integrations. One will be k1. K1 you need to compare, and then whenever you have numerical values, so you can compare and find k1, k2, and k3. That is the only job you need to do. Then it will be if you write it, then it will be ax square plus bx plus c divided by under root of the same quadratic ax square plus bx plus c, right? So you can cancel this, plus k2 into this is 2px plus q divided by under root of quadratic px. This is 2ax plus b, I'm sorry, derivative of the denominator. So this will be 2ax plus b upon ax square plus bx plus c and plus k3 upon same quadratic, right? Given quadratic ax square plus bx plus c. After this, you are getting k1 into Integral of quadratic, we have done this, right? So you know how to solve it. Just make it a perfect square and apply the formula. That's it. This is directly f dash upon root fx. So now directly write the answer of this, 2 root fx. So ax square plus bx plus c. Simple. And third one, you know how to integrate. Again, make it a perfect square. It is a quadratic in denominator, right? Ax square plus bx plus c. So this we have done. This we have discussed. This we have discussed. Just make a perfect square and apply the formula. And the middle one is already solved. Okay, so in this way you can solve quadratic upon under root of quadratic as well, right? So we have completed indefinite integration of irrational functions. Now from next session we will do uh, some more miscellaneous problems, difficult problems of this indefinite integrations. All right, so we'll practice it in 1 or 2 sessions and then we'll finish it. Then we'll start a new session. So I hope it is clear. So problem discussion session will keep in next upcoming sessions, and then we'll be moving to another topic. All right, so thank you very much for watching this video. Join the channel Let's Crack JEE and like my videos. Use the code JEET1 to get instant 10% discount if you take IIT-JEE subscription on Unacademy, and price changing from today. All right, so new price list, I'll update you tomorrow about the new price. All right, thank you very much once again.